Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, hope you are doing great. Inshallah, we will continue the rest of questions related to Kangaroo 2021. Let's move to question 21. Ahmed, Badr, Khalid, David, and Hashim are sitting at a round table. So I have a round table here, and those 5 people distributed around this table. Now, Ahmed is not next to Badr. So Ahmed can sit beside Badr. David is next to Hashim. So those, I can add them to the table, David and Hashim. Badr is not next to David. Again, Badr cannot sit beside or next to David. Now, which 2 people are sitting next to Khalid, the 5th person? Khalid. Who can sit next to Khalid? Let's see here. Since Badr cannot sit next to Ahmed and David, so I can put Badr here. So I can add Ahmed or Khalid. Those the 2 options that can sit next to David, because Badr cannot sit next to David. Now here Badr, they said, cannot sit next to Ahmed. So if I put here Badr, this is against this condition. So Badr cannot sit here. So I have to move Badr here and see Khalid to sit here. Let's see now the conditions. Let me move Khalid from here and check. Now let's see conditions again. Badr is not sitting next to David. Yes, he is not beside him. So this is correct. Now Badr is not next to Ahmed. And this is correct. Now the question is asking me, Khalid, who is sitting next to Khalid? Next to Khalid I have Badr and Ahmed. Let's check options. Ahmed and Badr, Badr and David, David and Hashim, Hashim and Ahmed, and it's not possible to tell, or it's not possible to be certain. From this, I can figure out that Ahmed and Badr are sitting next to Khalid. And this is the right answer for this question. Let's move to next question, question 22. Yummy, pancake. Let's see what is the question about the pancake. Rima asked the canteen chef for the recipe for his pancakes. Looks yummy. This is the recipe. Now Rima has 6 eggs, 400 grams flour, half liters of milk, and 200 grams of butter. What is the largest number of pancakes she can make using this recipe? So, in order to make 100 pancakes, Rima needs to have 25 eggs, 4 liters milk, 5 kilograms of flour, and 1 kilogram of butter. You can see that there is a difference between the measuring units in the question and in the recipe. So you have to change them into the same units. So this is 4,000 ml. Here, 5,000 grams. And this one is 1,000 grams of butter. So those are the units and the quantities. Now, in here, how can I decide the largest number of the pancakes? This will be very limited for the ingredient that I have or that Rima has the least, because as minimum as she has of, for example, eggs, she will stop here because she can't make more pancakes. Now let's see, based on the ingredients that she has, with the quantities that she has, how many pancakes can she make? Let's start. I will use this space here. And I can use also this space here. Now, 6 eggs. So, for 100 pancakes, I have this recipe or those ingredients. I need to find how much I need of each ingredient for 1 pancake. So, I have to divide by 100 each ingredient. So, this one by 100 eggs, I need 25 divided by 100, which is 0.25. That means I need a quarter egg for each pancake. For the milk, I need to use 4,000 divided by 100. That makes 40 ml. Flour, divide the 5,000 by 100. That makes 50 grams. And the last one, which is the butter, 1,000 divided by 100, that makes 10 grams. So this is the recipe per 1 pancake. Now let's see how many pancakes can Rima make of those ingredients. Now, using the eggs, since I need a quarter egg per pancake, she has 6 eggs. That means each one egg can make 4 pancakes. So this is Rima or Rima's quantity. Using the eggs, she can make 6 times 4. The eggs allow, those number of eggs allow Rima to make 24 pancakes. Let's see the flour. In order to make 1 pancake, she needs to use 50. She has 400. How much? So flour, she will make the 400 divided by 50. And that makes 8 pancakes. Let's see the milk. The milk here she has half liter. That means 500 ml. So the milk, she needs 40 for each 1 pancake. So this is the milk here. We will divide the 500 ml divided by 40. And that makes 50 divided by 4. That gives you 12 and a half pancakes. And the last ingredient, which is the butter, for the butter here, we have 200 divided by 10. Divided by 10, that makes 20 pancakes. Now, let's see the results here. She can make the eggs 24, but the flour can make only 8 pancakes. So regardless how many other ingredients, she will be very limited with the quantity that she has of flour. So she can only make 8 pancakes based on the quantities that she has here, and B will be your right answer. Let's move to the next question. The gears. Let's see. The picture shows 3 gears with a black gear tooth on each. So here 1, 2, 3, and I have those black teeth. Which picture shows the correct position of the black teeth after the small gear has turned a full turn clockwise? So let's move to the picture and see. This is the smallest gear here, and it moves clockwise. We need to know that after making a full turn, where will be the positions of the black teeth. Let's move. When this moves clockwise, can you see? Imagine this will move like this one will move like this, and the other one will move like this. Type. We determined the way that each gear will move, but let's see how many movements those gears will make. If this small gear make a full turn, let's see how many movements it will make. Let's see, starting from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 until it reaches the initial position again. So 10 movements. Based on that, let's count the same number of movements for the other two gears. Starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I'm expecting the black tooth here to be in that position. Let's move the other black tooth for the purple gear. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It will be somewhere here. So let's move to our choices here and see where are those black teeth for the other two gears, the blue and purple, because this one will return to its initial position. So this one, let's see. Can you see here? One at that side, which is not correct, and this one, it doesn't return to its initial position. This one okay, but this one, can you see it's far, and this one is far. Here, not correct. This one doesn't move. And here, this one okay, but this one is not correct. So the only one that has this situation is A, so A is your right answer. Let's move to the next question. Question 24, and let's see, since we can see fruits, an apple and an orange weigh as much as a pear and a peach. So this is the first sentence. This is the first condition in the question. An apple and a pear weigh less than an orange and a peach. And a pear and an orange weigh less than an apple and a peach. Which of the pieces of fruit is the heaviest? So let's translate the question in a way that can let us understand the relations between the fruits here. The first sentence, apple and orange, we will see, we'll use pear and peach. I will use those letters. So an apple and an orange weigh as much as, that means equal, pear and a peach. The next condition is apple and a pear. Apple and the pear weigh less than the orange and peach. And the last condition is pear and orange weigh less than apple and peach. Let's look at here. At the first position, those two sides were equal. Apple orange equals to pear and peach. Then we switch places between orange and pear. What happened? This side is bigger. Now let's move to another position. When we switch between the pear and apple now, which is the third sentence, again, this side is bigger. That means what? We changed the places of 3 fruits out of 4, and each time here they were equal. When I changed the pear and the orange, this side was bigger. When I changed the position of apple and pear, again this side is bigger. That means what? That means the peach is the heaviest fruit or piece of fruit out of the 4. They were equal. Any change happened here, every time I had a result that this side is heavier, this side is heavier. The only constant here is the peach. So peach is the heaviest fruit or piece of fruit in this question. And C is the right answer. Moving to next question. Question 25. We have 3 green colored squares shown in this grid here. What is the minimum number of additional small squares that must be colored green in order to obtain a green colored figure whose axes of symmetry are the 4 red lines drawn on the grid? Now let's see. In order to have those 4 lines of symmetry, I have to fill the following. See, in order to have this line of symmetry on this part, I will use this color here. Make a reflection around this line of symmetry. So do it like this. So you will fill here this, this, and that. This one, make a reflection here. Okay, but what happened here? I did this and this. Among this here, this line of symmetry, the vertical one, when I make like this, since I added that, I will add it here on this side. So here again is the same. Now reflect all those on the other side. So you will add this number twice. So let's count how many squares we added. 1, 2, 3. 1, 2, 3. Those 6, 7, 8, 9. And you will add 9 here plus 9 and 9, 18. Plus those. You have to reflect them again. So 9, 9 plus 3. How much? 9 plus 9 plus 3. This 18 plus 3. That makes 21. And 21 is the right answer. Next. That question. Moving to question 26. 3 pirates were asked how many coins and how many diamonds their friend Graybird had. Each of the 3 told the truth to one question but told a lie to the other question. So 1 correct answer and 1 wrong answer. Their answers are written on the piece of paper here. What is the total number of coins and diamonds that their friend has? So let's see the answers. He has 8 coins and 6 diamonds. 7 and 4 or 7 and 7. So let's translate and try to guess which one has the right answer and which one has the wrong answer. This one is weird because he mentioned the number twice. So let us start with this guy here, the third friend. We will assume that if this is a lie and this is the truth here, that means if this is a lie and this is the truth here, that means we have 7 coins and 7 diamonds. While move to the other friend, he said that he has 7 coins. So if this is a lie, this for this assumption that this is another lie. So this will be the truth. Lie, lie, truth, truth. So if this is a lie and this is a lie, that means that this one is the truth because one of them must be the right answer. And if this is a truth and this is a truth, those cannot be a truth because we need one truth. One truth. How can they have the truth? So this assumption was not correct because at the end I have here 3 numbers and I can judge. So that makes me to change the assumption, which is that was not lie, that was a truth, and this is a lie. Since this is the truth, that means that is a truth and this is a lie. That means that was a lie and this one is the truth. So this one, truth, that means this is a lie. So I cannot consider the 8. So how many coins? I have 7 coins. Here, lie, lie, and this one would be the truth, which is 6. So 6 plus 7, that makes 13, and C is the right answer. 13 pieces, 7 coins, and 6 diamonds. Okay? So the idea is that you have to start with the assumption. Since you have the number 7 repeated, we started that if this is a lie, this would be the truth. If this is a lie, this would be the truth. I have 2 right answers and that makes no sense. So we have to switch the assumption again and start that this is the truth. So those are lies. And this one, of course, it's a lie. And that was the right answer for the diamonds. So the total number of coins and diamonds they had is 13. And question 27. Question 27, here we have shelves, 1, 2, 3. And each shelf holds the total of 64 deciliters of apple juice. Now, the bottles have 3 different sizes. We have large, we have medium, and we have small. How many deciliters of apple juice does the medium bottle contain? So, I have different combinations on each shelf. The last shelf has only medium and small. This one, 3 combinations of the 3 types of bottles, and here only 2 combinations of the bottles. Now, how can I solve that? You need to look carefully for the bottles on each shelf. Here, I have 1, 2, 1, 2, 1, 2, 3. The last shelf has 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. There is a pattern. So I can have this as a pattern. 2 medium and 3 small bottles. 2 medium, 3 small. 2 medium with 3 small. The last shelf is your clue to start. So 2 medium and 3 small, 2 medium and 3 small. That makes half. Half of the shelf, 2 medium and 3 small. The other half, 2 medium and 3 small. That means I will start solving from here. The last shelf, 2 medium plus 3 small. That makes half of the total deciliters on the shelf, which is half of the 64. 64 divided by 2, which is 32. So 2 medium plus 3 small equals 32. Now, let's move to the upper shelf. The upper shelf has those 32, which is half of the total number of deciliters on the shelf. That makes here what? This is shelf number 3, and this is shelf number 2. Here, shelf number 2 has 2 big equals the half, because we said those half of the total number of deciliters. So 2 big equals to 32 deciliters, and that makes here divided by 2, that makes that each big bottle equals to 16 deciliter. Okay, now here shelf number 1, it has only big and small. So if you calculate here 3 times the 16 plus those 4 small equals to 64, right? Because the total shelf is 64 deciliters, while here I have 3 big bottles, and I know now the total number of deciliters inside each bottle. So 3 times 16, that makes 48 plus 4 small bottles equals 64. And now you can subtract. This is an equation that makes here 4 small bottles equals to that makes 16, I think, yes. That makes 16, and divide by 4, that makes each small bottle capacity is 4 deciliters. So 4 for the small, 16 for the big, and now our target is to calculate the total number of deciliters inside the medium. So easily here you can use the same equation that we used here. So I'll use it up here. We had 2 medium plus 3 small, 3 times 4, 12 equals 32. And let's subtract 12 here and 12 here. So 2 medium equals 20. That makes the medium equals 10 deciliters, and 10 deciliters is option number 4, which is D. D is the right answer, 10 deciliters. Okay? And it takes time to solve, but you need to start from the 3rd shelf, which is the clue that gives you that half of the shelf is 2 medium and 3 small, and move on for solving the question. Okay? Yeah, let's move to the next question, which is question 28. Now let's move to question 28. A large cube has side length 7 centimeters. On each of its 6 faces, the 2 diagonals are drawn in red. The large cube is then cut into small cubes with side length 1 centimeter. How many small cubes will have at least 1 red line drawn on it? So let's draw first. Let's draw the cube, which is the big cube. Let's imagine this is the big cube that has 7 centimeters here length, and then we have the diagonals drawn here, and of course on all faces of the big cube. Now this one is divided into 7 units here, so each small cube will have 1 centimeter side length. Now we need to know how many small cubes that may have at least 1 red line. So here we have the corners here. This is a cube. You need to imagine that this is here also, because it's a 3D shape on the other faces. So here, this one will start like this, but this one will not be included, all those cubes here. And there is one common cube will be here in the middle that has the intersection between this diagonal and that diagonal. So I'm expecting here to have how many cubes? 1, 2, 3 here. Since this is 7 and this is 7 here, I'm expecting to have 13. If you can draw and imagine here, you have 6, and the one here in the middle, which makes 7 on this side. And since this is a common, that means I will not count it again when I count the other squares on the other diagonal. So 7 and 6 on this face. On the face of the at the back, again I have 7 and 6. Now, what about the faces, side faces, top and bottom here? I said that you can here see that we have corners. Those are 3D cubes. That makes what? That makes me excluding those corners on each face because I already included them when I calculated how many cubes can be on each face passing or the diagonals passing through those cubes. So on each face, since I have 13 on each face, I will exclude for the other 4 faces 4 times 4 faces here times how many small cubes can be on the 2 diagonals. We said we will exclude the corners. So 13 minus 4, 13 minus 4, 13 minus 4 equals 9. So 4 times 9 cubes on each face, that makes 36. So in order to know how many cubes at least having one red line passing through them, I will add 36 plus 13 plus 13. That makes here 12 and that makes 6. So 62 is the right answer for this question. Moving to question 29. Now 29, a group of 10 people consists of either knights who always tell the truth or imposters who always lie. Here, so the truth and lie. Each one of them were given a card, here, those cards, with a different number from 1 till 10 written on it. They were each asked what number was on their cards and all answered with a number also from 1 till 10. Now, if the sum of the answers were, or the answer, sorry, the sum of the answers was 36, what is the smallest number of imposters here there could be in the group? So, if we assume that all of them are knights and they tell the truth, we have numbers from 1 till 10, 3, 4, 5, 6, 7, 8, 9, and 10. Or if all of them tell the truth, that means the sum of numbers from 1 till 10, that makes 55. Now, since the number, as they said, the sum was 36, that means they were imposters, and we need to find the least number of imposters. Based on what? Hala, you need to think if the imposter or the lie was giving overestimation, that, for example, if the imposter has 1 and he said, for example, 3, the sum will be 55. Since the number decreased, that means from those, and I need to look for the least number. That gives me the clue to look for the big numbers who can decrease the sum from 55 till 36. So 55, 0 imposters. Now, if it's 10, here for example, 10, that makes 45. Here, 9, but here 9, if you subtract 9, 45 minus 9, that makes 36. But it's not that easy, 36. The imposter, when he tells that he doesn't have 10, he needs to give another number. For example, if he gave 1, at least the smallest number here, that makes here plus 1, and here, of course, I will add another 1. So 46 minus 9, it will that gives me 37. And they said that the sum was 36. That means what? It's not only enough to have 2 imposters to have 36. I need one more. One more imposter. I need one more lie in order to bring this number down than 36. طبعا احنا we cannot guess which one was the incorrect answer or the lie. We need to guess only at least how many imposters I can have in this group. And here we can tell that I need 2, then I need one more in order to make this happen and make the sum equals 36. So at least I need to have 3 imposters in this group in order to have the sum equals 36. Let's move to question 30. And question 30 is the last question in this group. And now moving to question 30, which is the last question in this group of questions for 2021. There are rectangular cards divided into 4 equal cells with different shapes: square, star, dark circle, and triangle drawn on each cell. Those cards can be placed side by side only if the same shapes appear in adjacent cells on their common side. I will show you how can this happen on the figure here. Now 9 cards are used to form rectangular shape here, and which of the following cards shown in options A to E was definitely not used to form this rectangle? Now this is the rectangle that we have. Those are the cards. We have 9 cards. This is one card divided into 4 cells. So 1, 2, 3, and we have 3, 6, and 9. So we have 9 cards. Now let's see how can we put the cards here. If I wanna put a card here, I need to have a triangle and square. How can I find triangle and square? Let me check here. I have triangle and square, but they were flipped. So I can flip the card, and if I use it, I will have a star here and a dark circle there. So I used B. Now I need another card that has on this side star and circle. Where is the star and circle? I can use D, but I may flip it. So flip it to the other side. So I have star and dark circle, and I have, if you flip it this way, you will have a square, oops, a square and triangle. Okay, now I used B and D. Now let's move to the other line here. I need a star and a square. Star and square is here, so I can use the star and the square. Down here I have the dark circle and the triangle. So I have left here A and E. Which one of them is not suitable to be used here? Now I need a square and a dark circle here. I don't have them or this combination here, so I can use A here, square and dark circle. On the other side I will have the star and the triangle, and I can't use this anyway here to fit this combination. So E would be the answer for this question. This one cannot be definitely used to complete the rectangle of the 9 cards. By this, dear students, we had finished the Kangaroo 2021 questions. See you in another group of questions. Have a great day and bye-bye.